Today we will be talking about exponential functions. This is section 3.1 in your textbook. And the essential questions for this first section will be, what are exponential functions, and how do you evaluate and graph exponential functions? First of all, we need a definition. So basically, functions whose equations contain a variable in the exponent are called exponential functions. For example, the exponential function f with base b is defined by f of x equals b to the x, or simply y equals b to the x. Notice the x is the exponent where b is a constant. So what are some characteristics of exponential functions? So first of all, the domain, which is the values of x, consists of all real numbers. There are no restrictions as to what x as an exponent can be. It can be anything, whether negative or positive. The range, on the other hand, consists of all positive reals. The reason for that now you'll recall that b is a constant, but b is a positive constant. So b can never be negative, so a positive number raised to any exponent is always going to be positive. So the range, therefore, is going to be all positive reals. The second characteristic is that the graph for all exponential functions must pass through the point 0, 1. Now the reason for that is because if x is equal to 0, you've got b to the 0, and that's always going to equal 1. So all exponential functions must pass through the point 0, 1. The third characteristic is that if b is greater than 1, the graph goes up to the right. In other words, it's an increasing function. The fourth characteristic is that if b is between 0 and 1, the graph goes down to the right, or is a decreasing function. And the fifth characteristic is that the graph will approach but not touch the x-axis, so therefore the x-axis is a horizontal asymptote. Now let's say you want to evaluate the function f of x is equal to 2 to the x at x equals 3. So you plug in 3 for x, and you get 2 to the third, okay? And you can either calculate it manually, or you can use your calculator and simply key in 2, and then you'll see on your calculator this upside down V, which is called a caret, and then you plug in 3 and hit return, and you should get your answer 8. Now let's say you were asked to graph f of x is equal to 2 to the x. Well, using the characteristics we talked about previously and plugging in points, you can get a pretty good idea of what the sketch is going to look like. So from the characteristics, we already know that this graph is going to go through the point 0, 1. So it's going to go through that point right there. And then you can stop plugging in points. So if x equals 1, your answer is 2. So that's going to put it up here. If x equals 2, your answer is 4, which is going to put it like way up here. If x is equal to minus 1, you've got 1/2, which puts it down here. And bottom line is we can get our graph and get a rough sketch and find that it's going to look something like that. So for vertical translation, if you've got something like b to the x plus c, it shifts up. Or if you have b to the x minus c, it shifts down. And in both cases, it's c units that it shifts, either up or down. For horizontal translation, The c now gets added to the exponent. So if you've got g of x is equal to b to the x plus c, it shifts to the left c units. And if you've got g of x is equal to b to the x minus c, it shifts to the right c units. For reflection, if we've got g of x is equal to minus b to the x, then we know it reflects about the x-axis. And if we have g of x is equal to b to the minus x, then it reflects about the y-axis. We also have vertical stretch or shrink. So if our function is g of x is equal to c times b to the x, and c happens to be greater than 1, then we have vertical stretching. If c is between 0 and 1, we have vertical shrinking. So lastly, we have horizontal stretching or shrinking. If our function is g of x is equal to b to the c times x, it'll shrink if c is greater than 1, and it'll stretch if c is between 0 and 1. So now let's talk about a specific application, and this is when we'll be talking about compound interest. Now we have two different formulas for compound interest. Okay, if we are going to compound interest a specific number of times per year, then our formula is A is equal to P, parentheses 1 plus R over N, parentheses to the NT. A is equal to the amount that you have at the end of a period of time. P is your principal that you're originally investing. R is your interest rate as a decimal. N is the number of compoundings. And T is the time that you're investing for. For continuous compounding, which is what most financial institutions do currently, your formula simplifies and it becomes A is equal to P e to the RT. Now the only difference between this formula and the other formula is the fact that we have E in there, and E is simply the constant 2.718. Now I would like you to do the following problem. A sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years, subject to A, quarterly compounding, and B, continuous compounding. Please post your answer in the Dropbox, and we'll talk more about this next time.